Welcome to section 10.6, Trigonometric Ratios. According to Wikipedia, a ratio is a relationship between two numbers indicating how many times the first number contains the second. Let's look at some examples. If we look at the ratio of the number of circles to the number of squares, we realize we have 1, 2, 3, 4, 5 circles. And we have 1, 2, 3 squares. So our ratios of circles to squares is 5 to 3. Our ratio of squares, 1, 2, 3, to circles, 1, 2, 3, 4, 5, is the ratio of 3 to 5. Now our ratio of the total number of shapes to the number of triangles is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total shapes over 4 triangles. So it is 12 to 4. Now this can be reduced to 3 to 1, but it still stays in fraction form. Ratios will remain in fraction form. Here you see a triangle. This triangle can be named in many different ways. Each way will have a triangle symbol in front of it. As you can see, a triangle is named by its 3 angles. The 3 angles are angle M, angle O, and angle G. We also have 3 sides. Now traditionally, the segments that make up the sides are labeled alphabetically, but they don't necessarily have to be. Each side is a segment, so it has a segment symbol above it. We're going to be looking at trigonometric ratios. The trigonometric ratios are sine, cosine, and tangent. To determine these, we have to decide what the hypotenuse is, and then when looking at the legs, we have to realize which one is the opposite leg and which one is the adjacent leg. And these are looked at in terms of the angle. So take a moment and look at angle C here. Now, just like Pythagorean theorem, the longest side, and the side that is across from the right angle, is called the hypotenuse. The side next to the angle, next to C here, is considered the adjacent side, and the side that is opposite to C is considered the opposite leg. Take a moment and attempt to do the next problem, and then restart this video to see if you're correct. How did you do? If there's any confusion, make sure you ask me tomorrow. So we have the hypotenuse, which is the side across from the right angle, adjacent side, the side next to a given angle, and the opposite side, the side across from a given angle. Let's see how you do. Label the sides as opposite, adjacent, or hypotenuse. Go ahead and pause this video, do the labeling, then check back to see how you did. How did you do? Make sure you understand these 3 definitions before we go on. So when using measurements from the side X, the side opposite would be 12. The side adjacent next to will be 5. And the hypotenuse, which is your longest side and the side across from the right angle, is 13. Trigonometric ratios are always given based on a given angle. Sine is opposite side over the hypotenuse. Cosine of an angle is the adjacent side over the hypotenuse, and tangent of an angle is the opposite side over the adjacent. Now to remember this, many mathematicians use this saying, chief SOHCAHTOA. Chief is just to remember it, but we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Take a moment and work through this problem number 1. Then restart this video to see how you did. As you can see, for angle E, the opposite leg is the side FG. And the adjacent leg is the side GE. Now to complete the equations, we simply take the lengths of each side and then reduce them. So if I take the opposite leg over the hypotenuse, we're looking at 9 over 15. and of course reduce, that is 3/5. If we look at cosine of e, that's adjacent over hypotenuse. The adjacent side is 12, which reduced is 4/5. And for tangent, we look at opposite leg over adjacent leg. So your opposite leg is 9, and your adjacent leg is 12. Once you reduce that, you will get 3/4. When doing trigonometric ratios on a calculator, make sure you use degree mode. If you don't know how to set your calculator to degree mode, check with me and I will help you through that. Here's an example. We're going to find the sine of angle U. For sine is opposite over hypotenuse. So we look at the opposite side over the hypotenuse. The length of the opposite side is 12, the length of the hypotenuse is 13. For cosine of U, I do adjacent over hypotenuse. So I look at the adjacent side over the hypotenuse. The adjacent side has a length 5, the hypotenuse has a length 13. For tangent is opposite over adjacent. So from side U, opposite is 12, length of side, the opposite side is 12, and the length of the adjacent side is 5. Again, I'm using SOHCAHTOA, that saying, to help me remember which one's which, and that's something you'll need to memorize. To find the value of the ratio, you can simply put it in your calculator. To find the sine of 35 degrees, you type in 35, push the sine button, and you will see that that value is, rounded to the thousandths place, 0.574. Cosine, put in 102, because that's the angle we want to find the cosine of. Press cosine, and you get a negative 0.208 when I round to the thousandths place. And for tangent, I'm going to put in tangent of 87 degrees. I type in 87, and then I push the tangent button, and I get 19.08. Now this is the ratio or the value of, in the case of tangent, opposite over adjacent. The measures of the opposite side over the measure of the adjacent side. But to evaluate them, you can simply punch them in your computer. So looking at this, I see that I have the adjacent side and the hypotenuse. For adjacent and hypotenuse, that's cosine. Cosine of 73 equals the adjacent side, which is x, over the hypotenuse, was 6. And so I'm going to solve this like I would solve any other equation. I'm going to multiply both sides by 6. So in my calculator, I'm going to punch in 6 times cosine of 73 equals x. Now on the calculator I'm using, I have to do this part first. So 73 cosine, which is 0.292, and then I'm going to times it by 6. So my answer is 1.7542 equals x. In this case, I have the opposite side and the adjacent side. When I have the opposite side and the adjacent side, the thing to use is tangent. Tangent of an angle, in this case 68 degrees. Tangent is opposite over adjacent. So my opposite side is x, and my adjacent side is 21. So in this case, I'm going to figure out, because it doesn't really matter, the tangent of 68 first. So I type in 68 tangent, and I get that that's 2.475 equals x over 21. Now I'm going to multiply both sides by 21 to get x alone. So I'm going to multiply my 2.475 times 21, and I see that my solution to my x is 51.977. So that's my value of my x side. Let's see if you can try one. I'll get you started. We have angle 33, and from 33 we have the opposite side and the hypotenuse. Using opposite and hypotenuse is the sine. So sine of 33 degrees equals the opposite, which is 29, over the hypotenuse. Now this one's a two-step process. So first I have to multiply both sides by x, because with x in the denominator, there's nothing I can do. Now I'm keeping the sign of 33, but I could easily make it into its decimal equivalent. But it's good practice to be able doing it both ways. So these cancel, so my x is going to equal the value of 29, so put that in your calculator, divided by the sine of 33 degrees. I'm running out of room here, but I have 33 degrees sine, I know that is 0.545, so I'm taking 29 divided by 0.545, and I get 53.211. 33 degrees. So let's do a quick check and see how you're doing. Again, pause the video, work through the problems marked 19 and 20, mark how you feel about this material, and then turn this back on to check your answer. Let's see how you did. Okay, to find the sine of an angle, remember Chief SOHCAHTOA. Sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So how is finding the sine different than finding the cosine? Well, sine is opposite over hypotenuse, whereas cosine is adjacent over hypotenuse. I'll see you in class tomorrow.